All right, so we're gonna go over some of this stuff from Unit 3. All right, this is going to be on page 29. If you're not on page 29 yet, go ahead and flip on there. But I am gonna give you some vocabulary definitions, all right? And that's what we're gonna do on here, and we're gonna fill out some of this stuff. Um, Now when we look at this and we talk about any type of relationships, right? On an additive relationship, that means you're gonna be adding something, right? So when you have a graph, such as like this one, an additive relationship, meaning that I'm going to add it to that y, meaning my line will start anywhere up here at the top, right? Or it could actually also start anywhere at the bottom, like if it starts down here and crosses, right? An additive means that we're going to add or subtract it. We're going to move up and down that line. It's going to start anywhere except the origin. An additive relationship will not start the origin. It will start anywhere up above or anywhere down below that origin. That is an additive relationship. Okay. Then when we look at an algebraic equation, all right, an algebraic equation is going to have pretty much letters in it, right? Algebra, right? So algebra is going to be something like y equals mx plus b, right? Like that. That's like a slope kind of change that has some letters in it. When you look at it more with like numbers, it might say like y equals 1/2 of x plus 2, something like that. Those are algebraic relationships, okay? Um, you're going to be writing those down as you go. Now, the constant rate of change, right? This right here, that's also called, and I'm going to write it on this side, that is also kind of called the slope. Okay. And the way you find that is going to be the change of y divided by the change of x. Okay. We're going to go over some of that and how to figure that out. But the constant rate of change is that's called the slope. Okay. But you're going to find that by the change of y over the change of x. Okay. And it's not that hard when we solve it. You're going to see that it's kind of subtracting and then dividing, and not even dividing, it actually stays the same. All right, now dependent quantity, right? A dependent quantity is your y-axis. So this is going to talk about your y-axis. All right, so whenever you think of the dependent, right, is y-axis, meaning your independent is going to be your x-axis. Okay, so this y-axis going up and down, that is your dependent. All that means is this number is really going to depend on what your x is. So your y really depends on what's going on with the x. Like if this is miles and this was hours, well, it's really gonna, if you're not driving no hours, you're not gonna go up. But all of a sudden, if I drove for 2 hours, then yeah, I'm gonna drive some distance, right? I drove 100 miles. So this y really depends on what's happening down here on that x. That's what that is saying right there. All right. And the one way that I do like to remember that, like in middle school, y'all all starts getting boyfriends and girlfriends. I know I told y'all this, but independent means you're by yourself, right? When you get a boyfriend or girlfriend, you break up with them, they become your ex. That means they are independent. Your ex-boyfriend, your ex-girlfriend, they're now independent. Your ex should mean independent. All right. That is one way that I do remember what independent is. Okay. And then why depend on your ex? You broke up with for a reason. So why depend on them? All right. Multiplicative relationship, just like an additive relationship, right? An additive will cross up or down that axis. All right. On a multiplicative, right? When you have a multiplicative, if I have a graph for multiplicative, the one thing about that is means we multiply. Whenever we multiply anything to zero, it actually equals zero. So multiplicative will always cross that axis, that origin. All right. If it crosses anywhere other than the origin, then it's additive. But if it does cross that origin, it is a multiplicative relationship. All right. Now, when we talk about graphs and plotting and order pairs and all that stuff, an order pair is just a dot on the graph. That's all it is, and it is representing two parentheses, and you're going to put whatever number is on the x first, and then the y. Meaning, you're going to put whatever number is on the left to right column, and then you're going to put your up and down number. All right, and those are ordered pairs. When you put a dot, and you're saying, "Oh, actually, let me put the dot somewhere easier to read." Like right here, well, my x would have been 1, and then I will go to my y, which is 100. That is my ordered pair, okay? So those are what ordered pairs means. It's exactly what it is. At the bottom, a pattern, right? We learn about patterns in elementary school. A pattern is just something consistent. It could be something like a AA pattern or AABB pattern, or it could be even be a ABAB pattern, right? It is something that is consistent and that it stays consistent. All right. Rate, the rate is just comparing two things. All right. A rate is quantity one over quantity two, like miles per hour, right? I'm driving 5 miles in 2 hours. That right there is a rate. It's a rate because my bottom number is any number other than a one. All right. Uh, Representation is just what is this number representing? Like, give me a 10. What is that 10 representing? What does that even mean? Right. So that's what representation means. A table, it's not like a table where you eat at, but a table is like a graph table, right? And I'm gonna draw it over here on the side. All a table is, when you see a table like this, like when you have an X and a Y and they give you numbers right here, that's a table. A table could also be left and right, right? But it could also be like this, where X is the first one, where X still has to be the first thing I write, so X is on top. And then you could kind of make your table like this. These are two different ways to see a table. All right. Those are two different ways to see a table. And then the last one is unit rate. All right. Unit rate is very similar to rate, but a unit rate will always have a one in the denominator. All right. That one will always be a denominator, and you will solve for that X on top. So unit rate is whenever we put the denominator as a one. Okay. So with that being said, I gave you enough information to be able to answer these questions right here at the bottom. Okay. So if you didn't write the stuff down or you didn't listen, then you need to be able to go up there. So on this one, it says identify the constant rate of change if it exists. If there is none, then explain how you know. Okay. Again, the constant rate of change, that is the slope and of how is it changing. All right. So on this one, when I look at this one, you're gonna see that this right here, if I start at 0, and then on my one whole cycle, I end there, right? The way we find the constant rate of change, right, is the change of y over the change of x, right? And these are triangles. What does that mean, right? You don't know what that means. I'm going to show you what that means, okay? And I'm going to show you an easier way. The first thing you want to do is y over x, meaning I need to go up and down first. I need to find my y. If I start here, I need to see how long did it take me to get on that same level as the next dot. So I went up here and I went up here. Notice that, yes, I went up 2 blocks, but it is not worth 2 blocks. That y was actually a 50. So I'm going to put a 50 on top. My next number is going to be how long, now I'm here. Now, how long did it take me to get over here? This is called rise over run, right? The change of y over the change of x is also called rise over run. I'm going to rise and then run. So I went up 50 and then I went over all the way over here. Notice that, yes, I jumped 1, 2, 3, 4 spots, but down here, I only really went 0, 1. So I only went 1 space over. So my constant rate of change is 50 over 1. That is my slope. For every 50 miles, I drove 1 hour, right? This could be miles, this can be hours. Every $50, I bought 1 TV. Or for every 50 candies, I gave 1 away, right? So this is how you find that rate of change, a constant rate. It is rise over run, all right? Now, when I look at my next one on B, right? That is how you solve it on a table. All right. I mean, on the graph. When you solve it on the graph, you pick 2 different points, you go for it. I picked this point and I made sure that I found another point that intersected with 2 numbers. Then I did my rise over run. That is how you solve it on a table, on a graph. Okay. Now, when you go to a table, you're going to notice that you cannot make that graph now, or you can actually draw the graph and all that, but you don't have to. Okay. You could totally do it without that graph. This says A and B, but you need to recognize that my first letter is always an X. My second letter is always a Y. When I do this, is always rise over run, which means the Y is on top, the X is on bottom. So first I'm going to look at the Y, okay? And when I say the change of Y, when I'm doing this off a table, I'm only going to look at two numbers. I'm going to look at these two numbers because those are two are points. I don't care about these two down here now, okay? Now, my Y is going to be me subtracting those two. That's the change, right? Y2, which is the second Y. This is row 2. This is row 1. Minus Y1, which is 12 minus 3. Over X2 minus X1. Just like I did Y2 minus Y1, then I'm going to come over here. Again, this is my second group. This is my first group. X2 was 2 minus X1, which is 1. Then you just solve it. 12 minus 3, that is 9. 2 minus 1 is 1. So my slope or my rate of change is 9 over 1. Okay. Two different ways you could do it. I like this way because it's just simple subtraction. You just got to pick two numbers, two rows. It doesn't matter which rows, and then you just find that change of Y. I always pick the ones right next to each other because most of the time you won't have to simplify. If you pick the top row and the bottom row, then you might have to simplify at the end. But if you pick the ones right next to each other, you should be pretty good after that. Okay. Then when I look over here at this one, you're going to see that I have a formula. I have Y, I'm going to rewrite it. Y equals 9 over 2 times. Now, my constant rate of change, okay, when they give you an equation like this, your equations are always written, especially when you're dealing with graphs and tables, as Y equals M plus B. Okay, I'm going to erase that just so I could write it over where it's all on the paper. Y equals MX plus B. All right. Now, these letters mean something. This plus B right here, that plus B right there, that is going to be representing the Y set. All right. That means that's where it's going to cross this line. If there's no number over here, then it's going to cross at 0, right? If I had a, I don't know, if I had a plus 3, I will go up 3, and that's where I'll start my line, right? It can look easier on this graph since I have this graph. Maybe it was like MX plus 150. Well, if that's the case, at plus 150 at the end, meaning I'm going to go to that 150. I'm going to start right there, and that's where my line's going to begin. That means it's an additive relationship, right? It's an additive relationship because I'm adding at the end. I'm starting anywhere other than that 0 point, okay? They want to erase that part, but it's okay, I can rewrite it. That's what the whole plus B is, okay? That's what the plus B. The plus B is the Y intercept. Now, the other part of this, the MX. That MX, the M is your slope, which is also the M is the rate of change. Those two words are the same thing, the slope, the rate of change. So when I look at this, your slope is always stuck to the X because you're multiplying it to your X. When I look at this equation, I can see that that 9 over 2 is the X, meaning that 9 over 2 is my rate of change. Okay. So that's what rate of change is. Y equals mx plus b. M is your slope or your rate of change. Those two words mean the same thing. That plus b is your y-intercept. It's where it's going to cross this y-intercept. And whenever you have a plus b at the end, that's always going to make your relationship an additive relationship. Even if it's subtract, even if it's minus 10, It's still an additive relationship because subtraction is the opposite of addition. All right, so it still falls under additive relationships. All right. And then I come down here and I see a pattern, right? And when I look at this pattern, I see when there's one, I have two. When there's two, I have three. When there's three, 1, 2, 3, 4, 5, I have 5. When there's 4, I have 1, 2, 3, 4, 5, 6, 7, 8. Now, the reason why I'm showing you this because the two words that we're learning are slope and rate of change. And it should be a constant rate of change, meaning that change needs to be the same every time. Okay. But if I look at these numbers right here, I see from here to here, from 2 to 3, the way that I did that was add 1. Meaning it should be the same for everyone. But when I went from 3 to 5, you're going to notice that I added 2. When I went from 5 to 8, I added 3. So as we go, we can see that my rate of change is not the same. It's not constant. That is not constant. These are different increments every single time. So that right there shows you one reason, like, hey, this may not be a constant rate of change. Second part you're going to check is how did I could turn that 1 into a 2? Oh, that was times 2, meaning each one should work. When I do 2 times 2, I'm going to notice that 2 times 2 is 4, and that is not 4. Again, that is showing that my rate is not constant. I cannot multiply these numbers at the bottom by 2 every time to get that. That worked for this one, and that worked for this one. These two did not work, meaning that this does not work. I couldn't add increase at the same. I could even multiply it the same. So this one, when you have something like that, you are going to say that this one does not have a constant rate of, because there's no way to continue doing that constantly and equally all the way through. All right. Then letter E, you're going to see that on letter E says, I'm going to throw this down a little bit. It says, a farmer's market, Luisa sells 3 apples for 96 cents. So she sold 3 apples for 96 cents. And I wrote that wrong. Ever you're doing anything with money, you're comparing, like I had 3 apples, 96 was talking about dollars. Whenever you're comparing something, you're talking about dollars, I always put the dollar sign on top. The apples will go on the bottom. And the reason is that because whenever they give you something, they might ask you to do for unit rate. And whenever you solve for unit rate, you never want to find out when it's $1. You're always finding out like, how much did I spend for one item? Or in this case, you'll be like, how much did I spend for 1 apple? All right. So when you have something like this, you're going to fill this out. You're going to say, hey, I spent 0.96 cents on 3 apples. That is not my slope. I mean, that is not my rate of change. That is just a slope. That is just telling me one point where I can mark from $0 and 0 apples to 3 apples for 96 cents. The rate of change is how much is each apple, meaning that I have to find a unit rate of this. I need to find out when it's 1 apple. And the way that we do this, remember, whenever we solve unit rate, we just honestly have to solve this by dividing it, because all a fraction is just a fancy division problem. All right. But when you do this, you are going to divide this, meaning the 0.96 is the inside, the 3 is on the outside, that decimal is on the inside. You're going to bring that decimal straight up, and you'll just divide. You could say 3, 6, 9, 12, 15, 18, and then you're going to go ahead and tell me what the division problem is. And your bottom number is going to be a 1 because you turned that into a 1. And you're going to tell me how much you spent for each apple. That is my constant rate because every time she buys one apple, it's going to be the same price. So if she bought one apple, it's going to be something amount. When she bought two, you're just going to double that amount. And then when she bought three, that 96 cents is actually tripled the amount. So that constant rate of change for each apple was the same throughout the whole purchase. Those are constant rates of change. Okay. You do have to fill these out. You do have to solve these. Okay. As you see, when I go down, you're going to see that there's another picture. We are going to continue working on this, but you need to be able to solve all that stuff and show me all that work on that top side because those are all your notes. All right. Now, when I look at these notes down here on this second page, you're going to see that this is like the development part. This has all the notes that we just talked about. These are all the things that we just discussed, like the picture, determine how the relationship was. On this one, I had two, so it was 2 times 1. For my first figure, on my second figure, that's where I got the 1 right here. I got the 1 for figure 1, and I got 2 because there's 2 blocks. On this one, it was figure 2, figure 2. This time, I had 2 rows. 2 times 2 was 4. The constant rate of, and then 3, figure 3, had 3 rows. Each row had 2 blocks. So 3 times 2 was 6. Every time I multiplied by 2, multiply by 2, multiply by 2, multiply by 2. Every time I added a row, there was 2 in there. That means my constant rate of change is 2 because I was multiplying 2 every single time. And a constant rate of change is always multiplication because you're always multiplying those because that M and that X are always stuck together. Remember, it is Y equals MX plus B. Constant rate of change is the M. Notice how it's stuck to that X. But it's always multiplying. I always need to be able to multiply or divide because those are fact families to be able to get that constant rate of change. All right. If you look at a table, you're going to see that even on the table, you can say, hey, down here, I added 10 for each one. Over here, I added 2, right? So it's a plus 2, a plus 10. That means I have a 2 over 10. Actually, it's Y over X. Sorry, I always put that wrong. When you do change, constant change, it is always Y over X, meaning that this bottom one's going to go at the top. Every time I increase at the bottom, you're going to see that it increased by 10. That means my top number is 10. On my X, since now the X is on the bottom, you're going to see that every time it increased by 2. When you have that constant rate of change and you have this, you do have to simplify it. And this is an improper fraction, so you are going to simplify that by dividing it. 10 divided by 2 is 5. That is how they got the constant rate of 5. Okay, it is a constant rate of change of 5. I could say 2 times 5 was 10, 4 times 5 was 20, 6 times 5 was 30, 8 times 5 was 40. The constant rate is 5. I am multiplying each one of those by 5. Okay, that's what that means. When I look at this equation down here, again, an equation is, this is exactly what an equation is. Our equations are written as Y equals MX plus B, and the M is our constant rate. Okay, and that's all that is saying, that our M, that constant rate. On this one, the M is actually the 4, but it's whatever numbers before the X. This time it's a 4. M is just a variable representing a number we don't know. On that equation right here that they gave us the number 4. So 4x is actually mx. So my constant rate is 4. Okay. So when you see just an equation like this, that's how you're going to find your constant rate of change. It's going to be that one stuff to the x. Okay? It's always your m, and it's always mx. All right. Now, when I look down here at the bottom, you're going to see that the verbal, if they identify the value or the value is in a verbal representation, the number line the tiles used to create the pattern is 2 times the position of the figure. So the constant rate of change is 2. The reason why you know that is because the number of tiles used to create the pattern, a pattern means that it is consistent. A pattern is like AABB, AABB. It's going to repeat itself. That's what a pattern is. And it's telling you that the pattern is 2 times. The number is 2. The word times means to multiply. That is telling you that that is our constant rate of change. Again, rate of change is multiplication. Okay. You're gonna see you have to be able to figure out those keywords on this one. This is the same thing right here. How did I go? This is my X, this is my Y, this is my X, this is my Y, this is my X, this is my Y, this is my X, this is my Y. You still have to find these constant rate of changes. These are ordered pairs. They gave us 4 different ordered pairs. As you can see on the top, every X right here increases by 1. From 0 to 1, I increase by 1. From 1 to 2, I increase by 1. From 2 to 3, I increase by 1. Remember, we write these as Y over X. So since my first letter is my X, I know my bottom number should be a 1. As I look at my Y, which is my second letter, you're going to see from 0 to 6, I went up plus 6. Then from 6 to 12, I also went up plus 6. And then from 12 to 18, I also went up plus 6. Every single time, it went up 6. So my top number is 6. Remember, a fraction is just a fancy division problem. So 6 over 1 is just saying 6 divided by 1, and 6 divided by 1 is 6. My constant rate of change is 6. Okay. Again, that is, again, numerical way. When they give you ordered pairs, they can even give it to you in a table. You can do the same thing as a table. When you see that as a table, all that is just written differently. Instead of ordered pairs, to write that as a table just like this. I can split the table up, draw these across. I can say that this is my X, this is my Y, and then I can actually plug in those numbers. So 0, 0 will be 0, 0. 1, 6 will be 1, 6. 212 will be 212, and then 318 will be 318. So this table and these order pairs, it's the same thing. Okay, they're just showing it to you in 2 different ways. It's similar. That's why it says up there on the top, it is similar to a table, because a table is just our order pairs broken down. All right. Those are ways that you can solve that. Find those differences, put it as a fraction as Y over X, and then simplify that. All right. Now, with all that information, you're going to be able to solve these too. Okay. On this one, it says that Zach Jackson's community service for Boy Scouts last month he provided 4.5 hours of service per week. Notice that this is my X, this is my Y. Number of weeks. So if I didn't go no weeks, I am not going to do any service. No total service. I did not do nothing. There was no weeks per week. Now I went 1 week. Per week means every 1 week. For 1 week, I did 4.5. Then 2 weeks, you're going to do 4.5. I did it for 2 weeks. So now you're going to multiply that by 2. You're going to fill that out. Then 3 weeks, you're going to do 4.5. You're going to multiply that by 3 weeks. You're going to fill that out. You're going to fill out this table right here. Complete the graph and the data sheet tables. You're going to write an algebraic. Now from this table, you're going to say, this is my X, this is my Y, 0, 0, 0, 0. This is my X, this is my Y. These are my weeks. Notice down here it says weeks. You should be going to those week numbers. For 1 week, it's 4.5 hours. So this is my 1 week. You should make the dot on 4.5 hours. Notice that these numbers on this side represent hours. Once you find this, you need to tell me what my algebraic relationship is. So it's going to say Y equals, it's going to be an M. You're going to tell me what's my rate of change. How is it increasing? What am I multiplying these numbers by? It's going to say X. If you are replacing that in, what is my N? You can do any one of these strategies to find my, okay? And that's all we are doing. After you're done, you can